everyone. In today's video, we are going to talk about Karl Fischer reagents for coulometric sample. In the previous episode, we looked at volumetric reagent solutions from our Aquagent range. Today, we will introduce our coulometric reagents and measure the water content of a sample. Let's start with a bit of theory. Karl Fischer titration is the universally known technique for measuring water content. This reaction is what makes it possible where there is a stoichiometric relationship between the iodine consumed and the amount of water in the sample. Charlotte's reformulated Aquagent range for Karl Fischer allows you to measure the amount of water in many samples and at very different concentrations, with reagents of exceptional quality. Some of the advantages of the new formulations are a more stable and robust factor, faster stabilization, and a more stable endpoint. Now then, are you unsure when to use a volumetric reagent or a coulometric one? In general, we will choose a coulometric reagent for water contents below 0.1%, that is, 1000 parts per million, and a volumetric reagent for water contents above 0.1%. In today's video, we will focus on coulometric reagents. Unlike volumetric methods, in this case, the iodine is generated electrochemically in the measuring cell by oxidizing iodide to iodine. This reaction takes place at the anode when an electric current is applied. For coulometric methods, the measuring cell has two compartments, the anode and the cathode, which may be separated by a membrane or diaphragm. Charlotte offers Aquagent reagents suitable for both types of cells. The most commonly used version is the one without a diaphragm, although it only allows you to use it with conventional reagents. If, for example, we had ketones, we would have to use equipment with a diaphragm. The choice of reagent is mainly determined by the type of cell and the type of sample we have. In addition, we also have our latest release, the reagent for Karl Fischer oven, which is used for insoluble samples with a high boiling point designed for use with the Karl Fischer oven device. This is an alternative for when the sample does not dissolve in the conventional solvents mentioned so far. To finish, we are going to measure the water content of a coulometric sample. For today's demo, we are going to use a Mettler Toledo T7 coulometric device. This device can be used as either coulometric or volumetric, but today we will use it as coulometric. Previously, we calibrated the device with one of our standards, AQ0019. This contains 0.1% water and is suitable for coulometric method. For today's demo, we are going to measure the amount of water in an acetonitrile sample. Previously, we already weighed the syringe with the sample, and now we are going to introduce the sample into the cell. We weigh the syringe again to determine the difference in weight and enter the resulting value. For today's measurement, we have used our AQ0058 reagent. This reagent is designed for use in coulometric measurements and is our best seller among the coulometric reagents. If you don't know which reagent you need, you can contact our consultation service and we will help you choose the best option.